or good afternoon, or good evening. This is a video on two-step mole calculations. By now, you should have read the handout on two-step mole calculations. Plus, I also have an example of a one-step calculation, but you should have printed out at the bottom of this. You should have opened up or printed out the mole wheel, and you should have opened up or printed out the example of the two-step calculation. Okay, this is the YouTube video that's going to go right there, and this is the homework assignment. I believe it's only one with the answer at the bottom. So, going through this this handout here, basically what we're going to be doing is we're going to be using the mole wheel. And unlike the one-step mole calculations, which goes from the mass, which I call the spoke, one of the spokes, to the moles, which is I call the hub, or volume to the moles, or number of particles to the moles, okay, or vice versa, the hub out to the spoke. Those are all what I call one-step calculations. And an example of a one-step calculation is here. This is a volume calculation, and you look and you see that it's moles, and you're looking for liters. So if you use this mole wheel, if you had moles, this is your starting point, and that's your ending point. So you're going to use this equation or conversion factor, and that is what I did right here. This is dimensional analysis, the conversion factor. This is by equation, and you already know that because you already did one-step calculations. Now what we're going to do is two-step calculations, which instead of going from a spoke to a hub or the hub to the spoke, what we're going to do is going to go from a spoke through the hub, now let's say mass, to moles, and then to, let's say, volume. So we're going to go to spoke in my analogy. Okay, it's a wheel, that's why we have spokes and hubs. If you haven't got that yet. So how do you do that? Well, just like it says right in here with the steps, you're following the basic steps of any calculation in my chemistry class, which is you have known information. So let's get an example. Here's an example, and it says, what is the mass of 5.67 liters of CO2 gas, of CO2, which is a gas at STP. So from that, you know that you have liters. So you're starting here. So this is the starting point, and you're looking for the mass, which is here's the ending point. So you write down the starting information, and you write down where you want to go, which is grams. So that's the first thing. Then you want to figure out how to get there. And to get there is kind of the new thing, because before with one steps you only used one equation, one conversion factor. Now you got to do two. And what this will always be is you'll go, in this case, from volume to the mole. That's one equation or one conversion factor. But you don't want mole, you want mass. So therefore you're going to go from the moles to the mass. So you're going to use another equation or a new conversion factor. And for this particular one, since you're going to be using mass, you're going to have to figure out the molar mass of the substance. So that will be part of your calculations. So whenever you do a mass conversion, so if you ever use the mass, let's call it spoke, you're going to have to use the find the molar mass of the substance. So that's kind of what we're going to be doing. So I need to go get the example again. So that's what this is saying. Okay, 2A says set up calculation either by equation or dimensional analysis to go from the known information to the mole. So that's, in this case, from here to there. So we have this information. And then once we have that, then we're going to take it from the moles to the information we're looking for, in this case, from moles to mass. And then we do the calculations. Okay, and that's what 3 is. Do calculations, use sig fig, scientific notation, get the units you need, and you get the answer. So, how does that work for our question? So, by equation, which is the longer one, so what over here is I just explained that that concept using basically little hand explanations. So you're gonna have actually 2 steps, and I wrote out the units it goes to in the first step and the units it goes to in the second step, and I gave you the equations and conversion factors for each. You don't have to do this. This is for the people who really can't do the calculations and do the what equation next. So if your mathematics is not that great, you may want to write this like roadmap before you actually do the math. So, but if you're using the roadmap, what you do is you want to change the liters into moles. So in this case, by equation, I took the liter per mole equation, okay, which you use directly, okay, plugged in, and I get 0.2531 moles of CO2. Okay, it needs to have one more significant figure. You need an answer, and you need 3 in the answer. So then you're going to use that in the mass equation, because that's where you want to go. So you change the equation because you want grams by itself. You get that. You figured out the molar mass. That's up here. So you're going to do the molar mass no matter if you're doing it by equation or by dimensional analysis. So that's what it is. All molar masses have so many grams of the compound over 1 mole of the compound. That's how you write it. That's how the first part is written. You use it in here, and you get the answer in grams, and then you put the number of significant figures in the scientific notation. There's units everywhere. Now, if there's a number, there's a unit, and there's a symbol. That's how you do it. So if you do it by dimensional analysis, you start out with liters, and this is your first equation above. This will take us to the mole of CO2, and then you want the mass. So this changes it to mass. Again, if you do it by dimensional analysis, that whole thing must be done. So technically, you would have written everything up here, down here, but I didn't do that. Okay. So in that case, for dimensional analysis people, a 2-step, you just have 2 parentheses. Okay. And then you get your mass and you get the answer. Okay. So it's exactly like a 1-step calculation, except you're just doing 2. And what it does is it allows you to go from quote quote spoke to spoke. Okay, so give a shot to the question, this one right here with the answer at the bottom, and come in if you have any questions. Thank you.